This is called magic. We're learning physics together. It's magical. The next component will be something called resolving vectors. This is actually a pretty challenging part, but do not worry. Just follow the videos and you should be doing it quite easily. For example, what is the difference between a vector and a scalar? A scalar has no direction. Vectors have direction. So how do we incorporate direction into the calculations? For example, what do I mean by direction? If you buy a line of cloth, if it's 1 meter, okay, it's just 1 meter. It doesn't matter if you measure it from here to here or here to here. It's still 1 meter of cloth. But if you move it from one place to another, let's say moving from point A to point B, in order to show direction, first you have to choose the direction, positive to be this direction, and then your displacement here will be positive 1 meter. Okay, that means from this diagram, from direction chosen, you know you're moving from A to B. Try the other one. If I were to write like this, most of you will say, yeah, makes sense. Why? You're moving in this direction is positive 1 meters. If you move backwards, therefore, it must be negative 1 meters. Okay, so nothing special. You understand this, you understand this. Let's push this to the next level. 1 meter positive A to B. What is another way to write this? Another way to write this, which is mathematically correct, would be times 1. Okay? Y is still equal to positive 1 meter. What is another way to write this that is mathematically correct? You can actually write it as plus 1 meter times cos 0 degrees. Cosine, we're using trick here. What is cos 0 degree? 1. So you still have positive 1 meter. Most of you are wondering, why in the world am I suddenly putting this number in? You see soon. Cos 0 degrees means it didn't turn, okay? That means if you take a protractor, this is exactly at 0 degrees. What do I mean by you understand? Once you see the next one. You understand when I write it like this. For example, originally, you were here, positive 1 meter. You have turned 180 degrees. So, it's still a length of modulus 1 meters. But what is its sign? Easy. 1 meter times cos 180 degrees. It turned 180 degrees. What is cos 180 degrees? If you use your calculator, measure in degree mode, it's actually negative 1 meter. Okay? Notice, you know A to B positive 1 meter when direction to the right is positive. You know if it goes the opposite direction, it's minus 1 meter. Instead of just knowing, why not understand how, when it turns 180 degrees, it becomes minus 1 meter. Here's the understanding. Okay. So we use cos and use 0 degrees, 180 degrees. It's quite straightforward. What happens if, let's say this time, positive 1 meters, let's say you turn 90 degrees. Still, this is 1 meters. Okay, this is the modular sign, just to say that we're looking at a scalar value. Now you want to find direction. What do you do? In order to find direction, you have 1 meter times cos 90 degrees. What is cos 90 degrees? Cos 90 degrees is actually 0. So 1 meter times 0 equal to 0. Vectors, when they are perpendicular to each other, means it is completely destroyed in a sense. You turn it 180 degrees, it becomes negative. But 90 degrees, wait a minute, it is no longer there. Go back to a previous example that we have studied. If an object was thrown off a cliff at 8 meters per second, why in the previous videos do you see me stating that the horizontal or the vertical velocity is equal to 0 meters per second? It's because it is 90 degrees. Okay? You only have horizontal motion at 8 meters per second. Do you have any vertical velocity? When you're on a highway, 100 kilometers per hour, do you feel yourself moving up and down? No. Why? Because you only have horizontal velocity. Therefore, since you're not moving up and down, you should have vertical velocity of 0 meters per second. Okay, 0 meters per second. And how to understand that? Is understanding how to use cos. Positive, cos 0, positive. Negative, 180 degrees, minus. Now, cos 90 degrees means when you resolve the vector does not exist. I hope you understand the first part of resolving vectors. This is about how to use the cos one. If you don't understand, please replay this video and send me feedback.